Hi. So I'm going to talk about augmented reality. And remember to rate this session. A good rate, I hope. So, who am I? So, I'm a co-founder of a company called FieldSense, where we do analysis of satellite data for farmers. And then I'm also a software developer at the Alexandra Institute. And here I've been working a lot with augmented reality and trying to bring it into industry. And then I'm a computer scientist from Aarhus University. And that's where I started working with augmented reality. So that's a few years ago. And I was working with this concept of spatial augmented reality. And I think this is not that known. It's completely uninstrumented. So a user seeing this don't have to wear anything, or you see it through a phone or anything. This is just a projector projecting it onto a table here. And you see that you can actually look around and see it in 3D, perspective corrected. And even if the environment is changing, like this table moving up and down, we can keep the graphics staying in place. And I think that's kind of nice. So sadly, this is not very used. Usually when people see augmented reality, they want head-mounted displays. And I think it's very nice to not be instrumented, at least with the technology that we see today. So we can do all kinds of augmentations, but one drawback of this is obviously that it's a projector showing whatever we have of augmentations. And then if we put our hand in front of the projector, everything will break down, so the illusion dies. And that is obviously a problem that you have to work around if you're doing this kind of stuff. So that's what I did at university. And then afterwards I got hired at the Alexandra Institute. So here we're trying to merge science and turn it into products. So I think for augmented reality that's kind of valid, because this is a rather new technology, at least that it's becoming mainstream is rather new. So now we have to see how can we turn this into products. So today I will talk about, have this agenda of first talking about what is the vision for augmented reality. What is it and what can it do for us? Why do we want it? And then we'll talk a bit about where are we today? Where is it today? Is it actually at the vision? I think there's quite a gap between the vision and what it can actually do. And then the question, where are all these augmented reality applications? If this is the promised technology to change the way we interact with computers, where are all the applications? And that's because there are some limitations. And then I will talk about how we can work around them and actually build products today which do create value. And finally, I will talk about how we can move beyond these things holding us back, these limitations, and build something greater, at least, I think. So if we talk about augmented reality, I think Gartner's hype cycle is worth mentioning, because augmented reality is following it very nicely. So when a new technology emerges, people say, hey, what's that? It looks cool. And then the hype starts building. And I think for augmented reality, it has been building a lot. So this is a promised technology to change the world, and it will change all industries. And then what happens is that people are, there's a huge hype, but there are coming no products. And then people start to get disappointed and say, oh, why does it not provide any value to me? Why can't I use it? Why did I ever think this was the thing? And everybody's, sad. And then we can start moving up the slope. I think this is kind of where we are today with augmented reality, that a lot of companies are realizing this is actually hard. It's not easy to make an application that actually solves a problem for us. And then what I think we will see happen in the next few years is that there will start to arrive some products that we can actually use and which will change things as we know them. So first, what is the vision? What can augmented reality be used for? So this is me working for the Alexandra Institute, obviously doing augmented reality since I'm wearing these cool glasses. This is a HoloLens from Microsoft. And at the Alexandra Institute, I've been working a lot with industrial augmented reality. So this is where we're trying to say, how can we help manufacturing companies use augmented reality? So you want to enhance the workforce, enable them to do things they couldn't do before, work faster and more efficient and less error prone. So a nice thing about this, to work with industrial augmented reality is that we cannot just rely on the wow factor, that this is cool. We have to actually provide value, because after all, it's a question of cost-benefit. So if the boss has to decide on you should buy the product or not, it has to make you work faster. It all comes down to money after all. So this is an industry where I think is really interesting. Obviously, we've been told that now we will all be like Tom Cruise, throwing around random windows, and it will be so cool. The interaction should be amazing and fine. This is at least a promise. If you work as a architect or designer, it's nice to see your actual hardware and you can just put stuff on top of it. So if you're working on a tiny piece, you can see it on top of the actual hardware and see right where you need it, the information that you're building. And I think that's quite cool. And there's definitely some potential here. So I did this demo, I think 3 years ago, with a pump. But the pump is 70 kilos, so I will not bring it here. But I tried to replicate this demo with this weather station, which was a bit easier to bring. So, live demo, I hope that works. Seems like it. And you should see it too. A bit bigger, maybe. Okay. Nice. So here we have a weather station. And this is an object. And I think if you're a manufacturing company, you're usually working with objects like this. Kind of boring. It's made of metal and plastic. And you want to communicate it. So one thing it's really useful for is to say, I want to communicate what this thing does. So I can start augmenting it and do this exploded views and say, oh, this box here, I can unfold it and say what's inside it. Here there's nothing, but there might be something interesting inside it. And I think that's really cool. And you have this co-presence of the information that you need and the actual hardware. So you don't have this misconception. Is this the box I'm seeing down here? Or is it the box over here? Apart from the size, they look kind of alike. So if you're at conferences presenting products, I think this is quite nice. If you are teaching your workforce a new task, it's nice to instruct them on how the product work. So here augmented reality definitely have some potential. So I'm a computer scientist. I know nothing about hardware, but I had to go out and fix this weather station. This is from my company FieldSense, where we're building these weather stations, and I had to go fix it. I know nothing about how to do that. I had to replace a battery and move a wire, so I could get the instructions right on top of the object. So I had to detach a lid. Okay, I could expect that to happen, and remove the battery. Where is the wire I have to remove? All this information can be available straight where I need it, right on top of it. And now if I opened this box, I guess I could see what would be in there. So I have the instructions where I need them. There will not be any misconceptions of me going into the wrong box and doing things wrong. And finally, this is an IoT device. We have a bunch of these. There's a bunch of sensors, which might be interesting to people. And I think IoT is everywhere. We're having this weirdly intertwined world between physical and virtual objects. And we can only see the physical part. And then we have to understand the virtual part. And I don't know how we should do that. And one thing you could do would be augmented reality, right? Now you can look at the specific sensor, look at the specific object, and see what is the sensor for the wind, what is the sensor for the rain, what is the value of those sensors. And we can do all that. And all this is very nice. However, there's a problem with this demo. So if I try to visualize, this is my virtual weather station. Now let me try to move the physical one. They don't align now. I broke my system. And this is important because it's very easy to do a prototype like that one. But I'm cheating. I cannot create a product from this because now they don't align. And in an actual product, this should be allowed, right? So that was a bit about the vision. Now let's talk about where we are today, because as I showed you, some of this is hard. So some hard problems have been solved. We are quite good at tracking how our camera is moving in space. So if we're having a phone, we're tracking how our physical camera is moving. And if we can do that, we can align our virtual camera. And this is what is required in order to stick the virtual augmentations at the right place in the world. We're also quite good at detecting surfaces and doing estimations of light such that it looks realistic. And the surfaces is nice because then we can put them, objects into our room. So one thing we're really good at is throwing windows on our walls. So now I guess we don't need a TV because now you can just look at a virtual TV. Or 2 TVs, because that's cool. You have to wear these really uncomfortable glasses, so I don't know if that's a trade-off you want. And I'm a bit unsure on why you would want a virtual TV. I think a TV is solving the problem of seeing something on a screen quite well. So another thing we're really good at is putting objects on the table. And this looks really cool. And I think it's nice, this interaction, that you can control your camera and look around it just as you want. The problem here is that there's no relation between the physical and the virtual. I think that's weird. I don't know why I have to put this on a table. I could do this in VR. I could just do this on my tablet and using the sensors. Then I don't need to have this notion of how I'm moving according to the world. I just have to move the camera. That's way easier. So it's cool, but I don't see the relation between the physical and the virtual objects. And this is the difference between the kind of applications we're seeing today and what I did here. With the weather station, we have a relation. So let's try to create a augmented reality application. So at my company, again, we're doing this, creating this application called Snail Tracker. And it's basically tracking snails, and then you can see the pressure in different parts of Denmark. Where are the snails? And this is nice. It solves the problem, right? So now let's make this 1,000 times better and do it in augmented reality, because obviously it's 1,000 times better then. Something like this. Yes. So, oh, it changed that. I guess you can live with that. Now I can see my floor, and because it's augmented reality, I have to do a scan. But I guess that's okay, because now I can get an augmented reality. And look at this. Now we can see Denmark. It's the same information. Well, at least the important parts of Denmark we can see. So the information is here. It's available. But I don't see how this provides me with anything I didn't know before. I actually get the same thing from this 2D application. And I think this is a thing we have to think about when we're building augmented reality applications. So what else can we do today? Snapchat. That's a really popular app. And we can do this kind of stuff. Now I'm wearing glasses. It's a great time to be alive, right? When you can do that kind of stuff. And it's cool, and we're really good at solving these specific problems, like tracking faces. That's the thing we're good at. I think this is a very useful app, and it's a great application. So the IKEA catalog, you can see your furniture, but what you really want is to see how will this look in my living room or at my office. So now I can put up this chair. I guess I should have an actual office chair for this table, but I can put it in here and see how does it look. What is the scale? Is it correct? Do I want something else? Before I buy it. And I think that is really cool. And what you see here is that there's actually a relation between the physical world we're in and the virtual objects we're displaying. And I think this is a thing I want to point out. It is important for the application to make sense. You can't just copy-paste this. In Denmark, we have PostNord, which is our postal service. So they have the same the products, right? They have packages. So now if I put my delivery on the floor, I can see that just like IKEA, right? It's the same application. It's great. I'm just a bit unsure on what I'm supposed to use this for. You know, the wow factor is that it's cool. I can see my package. So if I have this white table and for some reason my package has to be put on that table, I can do that and I can see it. And obviously I can't rotate it, right? It has to be placed like this in order. And that's great before I even got the delivery. So we can do stuff. We can definitely implement augmented reality. But what is holding us back? Where are all these augmented reality applications which should change the way we interact with computers? So I think there's a term which is interesting here. And this is where it gets slightly academic, but try to follow me on this. So there's this concept known as extent of world knowledge. And I think this is what describes the difference between the prototype I showed you and what we have today. So if you ever worked with augmented reality, at least in academia, you probably know about Milgram. He said that we have this mixed reality continuum, and you have virtual reality and augmented reality. They have a relation. Then if you read on in this article, you will see that there's also this concept of extent of world knowledge. He actually says that this mixed reality is not good to explain the differences between applications. But this is a typology of describing what are the different kind of augmented reality applications we can have. So with extent of world knowledge, it's the question of how much do your system know about the world. So you might have a completely unmodeled system where it knows nothing. Then it's hard to do augmented reality. And then you can have a completely modeled system. This is usually what you have in virtual reality, where your system knows everything about the world. In virtual reality, because you've created the world. So if we have no knowledge of the world, I can do augmented reality like this. There's a cow. Then I move my camera. The system does not know that. So now the cow stays in place, and that looks weird. If we know a bit more, like what is the camera motion, then the cow can, and what are the surfaces? The cow can stand on my shoulder. I can say hi to the cow. And I can start moving the camera, and it stays there. And this is what we're good at doing today. And this is what enables us to do augmented reality. And there are out-of-the-box tools for this. AR Core and AR Kit are solving this. So this is the granularity of what our assistants are seeing. This is from a HoloLens, the mesh that you will get if you scan a room. So there are some people. Can anyone see what this is? It's a warehouse. So it's different boxes standing in a warehouse. And usually what you would want is for your system to tell you what's in those boxes. Where are the boxes? And all that information is kind of hard to extract from this. So if we put this in my living room and see here, I can definitely see that there are something here. I can see the overall shapes, but I can't see this is a couch. Obviously, my lamp is not even seen here. So the granularity is really low. And this is fine if we just want to detect surfaces. So say, there is something here, there is something here. And that is useful. If we're building games, we could make a guy like this, walk around, jump down on the floor, and that's cool. It's great. And I think this is what makes this feel like they're actually in our world. So this is important, and it's a huge step. And it's only recently that this is easy to do. And we can do this on a phone. We can do this on HoloLens. So we're very capable of detecting camera motion. We are very, very good at detecting markers. So if we want to know something about the world, we can put up markers. But I think that is a fallback mechanism. This is, I want to know something, so I have to augment my world physically in order to augment it virtually. That's kind of weird. But of course, we can do that for some applications. We're rather good at detecting the overall environment surfaces, and we are somewhat capable of tracking specific objects, and I will talk about that later. But that is one of the problems. So I think in order for that application to work, what we need is SIG stuff tracking. So we need a rotation and a translation of our objects such that we know exactly where the object is, what object we are looking at, and how it, so I can align virtual content on top of it. Another thing holding us back is interaction. So natural interaction is one of the arguments for using augmented reality. Now we can, like Tom Cruise, throw things around, and it looks cool. And it might be even half as effective as if you did it on a computer. But even the basic interaction in augmented reality seems to be somewhat weird. I've never tried to give a person a HoloLens and he just used it out of the box. It was always like, I have to keep the HoloLens behind my back and then tell him, you have to do like this. And somehow this often becomes this gesture, and I have no idea how that happens. But it feels so unnatural for people to do this. And I've never interacted with an object over there by doing this. So I don't know why this should be easy or good. And I even think there's some research saying that this is not a good way to interact with stuff. But we want that. And then finally, there's the thing about content creation and data quality. And I think especially if you're working with industrial augmented reality, this is important. Because then you have to scale things to an entire product portfolio. So I could create a prototype like this, and we have the technology to display stuff, but what should I display? But what if we have 1,000 products? And this is the case for companies like Grundfos or Lego, or if you're working with those guys. Then how do you generate content? I want to have all my workers build stuff, have these instructions on how they should fix a problem, like I showed before. The problem is just somebody has to generate that content, right? And there's, again, this cost-benefit. Is it worth it to build an application for every single item we have? So that is why we have to automate this process. And this should happen all the way down to the core 3D data you're building. And I don't think many companies are there yet. So this is a hard thing. So now I said that there are some limitations, but this does not mean that we can't make augmented reality applications. We definitely can. We just have to work around and know these limitations and work around them. So I have a few tips on what I think you should do. So the first thing is keep it simple, but create value. Always try to minimize it to the minimum case where you're actually solving a problem. So here's an example. This is done quite a lot of time ago. So what we did here was to have this lid, and the problem was that they somehow forgot to put a cooling pad on top of it. So what we wanted to do was to say, we can instruct people on where this cooling pad should be, and it has to be very precise. So what the worker had to do was to take the cooling pad and put it at the right location, and then send it to quality assurance. We would send it back and say you did it wrong. And then they have to do this over and over again. And this application is super simple. We just put it on an iPad, detect the object, and say, you have to put it here and here. And one thing which is interesting about this case is that you actually need the physical and the virtual information at the same place. You don't need to do this mapping of looking at a screen, where should I put it, what is wrong, and then looking down on the object. You can see it where you need it. So I have a video of this, where a person is putting it in, try to put the cooling pad on top, and validating that it's done correctly. Actually, for the other cooling pad, you see that trying to fix it within the boundaries of the box. It's really simple, right? There's not much interesting about this application, but it actually solves a problem. And it was easy to build. There's no requirement of content creation because the content is just these red boxes. That's easy. And there's a super limited scope. Another example is that you can sometimes ask your users to provide the world extent, the knowledge about how does the world look like. So as I showed, we can put things on a table. So here we have a scaffold, and we can visualize it. And this is interesting if you want to talk about it, but it does not help the workers in putting up the scaffold, right? So how can we visualize this in full scale at the right location? So what we could do is to say, this thing has to go here, this thing has to go here. And this is what you do when you build them. You go around and put these flags in the ground saying, this pole has to go down here. And you put another flag. And then you validate it and walk around. Did we put up the flags correctly? Now you can actually see it, because we're just saying it has to go here and go here. And now it's available in full scale. And we can see it right here. Is this correct? Even before we build the scaffold, we can see, is it correct or wrong? And this is interesting because, as you see here, it's obviously wrong. It's going straight into a building. So we have to do something different. This is, after all, we're saving money, right? It would be a bad thing to figure this out while you build half of it. And then, of course, there's this validation part. When you have to validate, did we build it correctly? You can walk around and look at it, and usually what you do, then you have a blueprint, right? And see in 2D, there should be a line here, and then you look up, that looks correct. This is hard. This is something we're not good at, mapping from 2D to 3D. Here we can actually we have the entire 3D model on top of it, and we can just see, does it align with the virtual and the physical? And if it doesn't align, we probably did something wrong, either in the virtual model or in the thing we built. And there's this case of remote assistance. I think this is the thing we will see first in industrial augmented reality. So remote assistance is this, that you have a technician or an operator who has a problem, and then he calls for an expert. And experts are expensive, and there are only a few of them. So then the expert can say, oh, you should just do it like this. And they can start drawing stuff, and you can see the drawings in augmented reality. That's really cool. The nice thing about this is there's no creating of content, because that's done on the fly. You could even record the session, and then you have documentation for later. You don't need to understand much about the world, because a person is pointing and saying, this is where stuff is. So this is also a highly generalizable use case. All companies who are building things in large scale have this problem. So I think this will be what we see. And actually, I just got a mail a few days ago from TeamViewer that now they have this in augmented reality. Skype has it too. So this actually exists. But I think for adoption, something has to be done. And we did some experiments with this. So I would say that the golden standard for communication is probably that you have a person standing next to you, right? Then we can talk to each other, and he can point at stuff, and he can gesture at me. So we tried to build this, that this should be the basis of your communication. It shouldn't be a video stream which can break and have bandwidth problems, and you have to look in a specific direction. You can just communicate with this person, and then you can have videos aligned with this, because obviously you want to see the object. But then you have this person standing next to you. That could be an expert in virtual reality, and he can see, where you are. So this black thing is the phone, so you can see where am I standing, and then he can see where it's the model, and he can start pointing at it, and I can see where he's pointing. So I have this guy standing next to me, and he can express himself. He can talk, and he can wave. Hi, you're a nice person, I guess. And you can point at stuff and give me instructions. So this is nice for communication. And he's just standing in his virtual reality, because experts like to stand in virtual reality. You could also do this with a phone or a computer, but once again, we're trying to make the golden standard, right? That something should be cool. So now we're talking to each other, and he's saying, look at this. You might hammer here. Okay, I start slapping it. That's good. We can talk with each other and actually feel like the person is here. I think a great indicator that this is somewhat correct is that I actually got the feeling that this guy standing next to me, even though he's virtual and looking kind of weird, I can see this is not a person. When he moved towards me, I wanted to step back. I did not want to have this guy walking into my intimate sphere. And I think that's nice. That shows that we can interact with each other. So we're capable of working around current limitations. But we also want to be able to track objects, right? We want to be able for this to work, and we want this prototype to work, because if we can do that, I think there's a lot of valid, a lot of interesting things that can take place. I think we can implement most of the vision that we actually want. So how can we improve the extent of world knowledge? One thing we can do is that we can cheat. So the easiest way and the most often seen way of cheating is that you put up a marker. So if you, and this might be completely valid, if you have a use case where you're looking at a specific object standing at a specific position, you can just put a marker there, and then know that then you can align everything according to that marker. That would be a great thing for the remote assistance case I showed you before. So that is one way of cheating. You can also think outside of the box. Don't only think about what your phone provides. Don't only think about what you can get from the HoloLens. There are these sensors. But with the phones, at least, we're limited to the sensors on the phone, which cannot do that much for us. It's just a camera and accelerometer and stuff. Then we can start using external sensors. So if we have Kinect cameras looking into our room, these depth cameras, depth is interesting when we want to do object segmentation and object tracking. So we can use this outside-in tracking. This is also what you're doing in virtual reality to get a much better view of what you're doing. So this is an example from one of my colleagues who is combining a bunch of streams from Kinects. And this resolution is quite high compared to what you saw with the HoloLens, right? And you can track people, say, this person is moving around here. You can even track how he has moved over time. So all this kind of information can be fed into your system. This remote assistance applications I showed you before, some people have been trying to do the same thing, where they do the scan with a Kinect, and then you have this really cool-looking avatar standing in front of you, who's not just a white guy, which is weird. The other thing you could do is to try to extend the system's understanding of the world directly in the system. So what do you have available? On a phone and on a HoloLens, it's a camera. The camera is what gives you the most information. So computer vision is very interesting here, right? So currently there is a silver bullet within computer vision, and that's deep learning. We've been hearing a lot of deep learning recently, and it just solves a lot of problems. So the thing about deep learning, though, is that it requires large amounts of training data. So we have to train them to solve whatever problem we have. And often when you train them, they're trained on very specific things, so they don't generalize. Again, if you're a company and you want to track objects across your entire portfolio, then you have to train it to work for 1,000 different objects. So what you could do would be to take a phone and have a person walking around taking 1,000 pictures of the first object from different angles, different directions, different distances. Then you can take the next object and do that again. That's not feasible. You shouldn't do that. So we tried to do this in another way. So what we did was to train on renderings. Usually, if you're a manufacturing company, you have 3D objects of whatever you're selling and building. So you usually also know what kind of materials are they made of. And if we know that, that's enough to make a render, which is kind of realistic. So here we have two different objects, a Tetris controller, apparently, and a motor. And we tried to train it. So the first thing you would do in machine learning, right, detect what am I looking at. This is the basic computer vision application. So here we have a Tetris controller. This is nice. And remember, this is trained purely on rendered images, but it works for actual images. I think that's quite nice. And here the motor is. And as you see, scale matters. When I was too far away, the motor is not a motor, it's just background. So this has to definitely be trained on the right data. Then you can go beyond that and say, I don't just want to know what I'm looking at. I might be looking at several objects, and where are they? So we can also do that. That seems to work just fine. Again, purely trained on synthetic images. This is real time. So what I wanted was this. You had this bike, and I wanted to put stuff on top of it. I have this weather station. I want to put stuff on top of it. So I need this SIG stuff tracking of it. I know it needs to know the rotation and the orientation of it, not just a box around it saying where it is. So we're trying to train a neural network for that. So what we did was to say that we need to detect the specific features. So we have 48 features for the weather station. So in the top row, we see the rendering. This is a rendering of the weather station. And this is the features the system should output. So this is what we want from our neural network. And this is what we get from an actual image. Kind of the same features, slightly more blurry, but this might be acceptable. If you have enough of these points, you can just minimize a matrix and you have your rotation and your translation, which is what we want. So here it is for the Tetris controller. And it most of the time works fine. But what we want to do is basically to detect it once or twice and then just rely on AR Core or something, regular SLAM to track the object. And then what you see to the side here is all the different features being tracked. So here we have it for the weather station. That even though we're turning it around and seeing it from different directions, it seems like we're always capable of finding at least some features. So let's look at this in real time, and real application. So here we have the weather station. I never told the system where it is, like I did here. And after a while, once it has detected it, it will say, there it is, I can put augmentations on top of it. And I think that is really cool. This is the application I showed you just now that I did not cheat. This actually works. So I think we're moving towards this. And there are other companies doing this. Vuforia have their object tracker, so there are other guys who are looking into this specific problem. But I think it's not solved that good yet. Actually, we trained our network here on incorrect data. So the model of the weather station was not correct with the weather station that we see here. They did not align completely. So I think it's nice that it actually still works. And this is usually the case when you're talking with companies. They give you a model and it's like, yeah, that's kind of how it looked a year ago and not how it looks today. But I think it's nice we solved some of these problems. And this is also why I think we're definitely going up the slope and seeing new objects emerge. So to summarize what I've been talking about, it's important that you identify a suitable problem. Augmented reality does not work for everything. Keep it simple while you provide value. This is important. And I think you should think twice before just throwing random windows on top of walls. Thank you.